up we have David Lee representing our platinum sponsor Vision Dealer, and his talk is titled "Why is encoding so hard?" Seriously, why is encoding so hard? David is the VP of Video Solutions at Vision Dealer with more than 20 years of experience in development, technical pre-sales, sales and consulting, with hands-on experience defining and developing products in digital media, healthcare, ad tech and e-commerce. David has worked in companies of all sizes, starting from startups all the way to their IPOs, as well as medium and large companies. Over to you, David.
Oh, it is on. Thank you, Krishna, very much. So thank you guys, very nice to be here today. My name is David Lee. I come from Vision Dealer. I'm the Vice President of Sales and Solutions. And I won't take up a lot of time because I know I'm the last talk before we all get to go to lunch. So I'm going to tend to go pretty fast. If you have questions, we have a booth outside. We also have a Guess the Bitrate competition. We're giving away a JBL speaker. If you kind of have a look at the two videos side by side, figure out what our output bitrate is, make a guess, you have a chance of winning a prize. Has this ever happened to you? Have you guys ever watched content? Obviously not Hotstar because they're doing amazing things in terms of buffering and figuring out QoS, but if you, show of hands, anybody ever watching a sporting event and the stream is just frozen? Yeah, okay, I'm sure those of you have your hands up, yes, I agree with you. Those of you don't, you're lying. I think you probably all, everyone's always seen this. Streaming is hard. In all likelihood, when you have a stream buffer, you have a problem, as Ramesh obviously knows, your video compression or something around the playback is at fault. So poor video compression leads to, obviously has a big impact on the user, right? It leads to poor video quality, higher than necessary bit rates, poor encoding density, and slow encoding speeds. What we're really trying to say with this is encoding is hard. Why would you spend all this money on apps, acquiring content rights, you build this multi-million-dollar streaming service, and your video transcoder is the slimmest part of it. If you don't spend time and energy working on your video transcoder, the chances are your transcoding, your service could actually fall like a kind of a badly assembled Jenga tower. Okay, so you might ask yourself, can I simply just buy a new transcoder and slap it into my video pipeline? You could probably do that, but understand that video compression is hard. It's an art as well as a science. There's a lot of things that go into factors that go into video compression that we'll talk about here in a second. This is probably very reminiscent of the things that Ramesh was talking about. You need to balance all of these things when you're setting up your video encoder. You need to take into account which codecs you're going to use, which profiles, which tiers within the codecs, right? Resolutions. Do I want to have a 4K experience, or I just want to have 1080? Do I need to have, how many resolutions of 360, 540 SD do I need to have in order to make sure I have good switching and good playback for my users? Obviously, bit rates play a very important factor in that as well, because the larger the file size, the longer it takes for that device to actually load those content chunks and start playing them back to the user. So we'll talk a little bit more about bit rate efficiency as well. But obviously, streaming is hard. One of the things I would say is that when we looked at the streaming as a problem, encoding as a problem, we realized there were three main factors that go into it: speed, quality, and the size of the output file, right? So those are the three main levers that you have with a video encoder. You could say, I want to encode really fast. There are other things that happen when you do that. If I want really, really high quality, typically you have to go very, very slow. If I want, so again, if you want to have high speed encoding, typically what happens is your quality of the video output suffers, and you get very, very high bit rate because you're not doing much between the source and the output content. If you want super, super high quality videos, what happens is you usually have to go really, really slow. You have to spend a lot of time encoding that video using lots of algorithms in the encoder to make sure you can compress it really well. That results typically in larger videos. If you want to target low bitrate videos, you end up usually having lower quality videos and longer encoding times. So encoders use complex algorithms, right? There's lots of things that go into it: motion compensation, motion estimation, mode decision, quantization parameters, rate control. There's a lot of really technical things that go into how you build an encoder. And after analyzing millions of clips, we understood that basically there are three vital components in video compression. So was there a question? Sorry, I heard somebody talking. So basically what it comes down to is how do you make, it's an optimization problem here, a very kind of advanced optimization problem of trading off quality, speed, and size to get the desired outcome that you want. So one of the things that we look at here, for example, if you look at these 2 frames of a video, we need to understand which partition structure leads to the most optimal compromise of quality, bitrate, and speed. So inside your encoder, when it takes a frame of video, it's going through here and saying, how am I going to compress this? How am I going to make sure that I don't lose video quality, and I actually can decide, okay, how motion changes from frame to frame, and it makes a bunch of decisions. And so the more partitions you have, usually the higher bitrate you're going to have, right? And so making that decision here is very, very important. Also things like region of interest. In my previous life, I actually stuck people into functional MRI machines, showed them images, and actually started to figure out where their brains lit up. And you realize that humans are pretty much hardwired to actually look inside the video to say, okay, there's people talking, you're looking at the faces. There's text on the screen, you're looking at the text. If there's movement on the grass with jersey numbers in a player, you're looking to look at that number. It's just what we're hardwired to do. So if you know you need to specify or put emphasis on specific regions within a video, you can actually kind of adapt what you're doing as well. But this is all pretty tough, right? This is not for the faint of heart. There's a lot of decisions, and as this guy's looking at all the panels and things that have to happen, this takes a lot of effort. So Vision Dealer was founded on the premise that if the algorithms inside the encoder could take advantage of modern tools like convolutional neural networks, machine learning, other parts of AI, the encoding would naturally benefit. And we like to really solve hard problems. So first we said if we know that from the human visual system, faces are very, very important, how quickly can we determine, when you're working on live video, you have to go very, very fast, where those faces are. Now it's important to know, when we actually built our lightweight face detector, we don't need to know it's Asha, we don't need to know it's Krishna, Avi, or anybody like that. We just need to know it's a face, right? Humans at this point in time just need to, they're going to connect with somebody in their face. Eventually you'll figure out who it is. But when we're encoding it, we don't need to know it's a particular person. We just need to know there's a face there so we can allocate more bits to it. So we built a very, very fast face detector that operates in under 20 milliseconds. The next thing we care about, to my point here, we care about text. You all read the text that's up here on the screen because that's what we're hardwired to do. So if we know that there's text inside a video, we want to spend more time, we want to allocate more bits to that text because we know that humans are going to read that text. And if the text looks not very good, that's going to affect the subjective evaluation of that video. The last thing I would say that we do around AI, after looking at those millions of videos, we need to understand lots of different things about it, right? We need to understand the blurriness of it. Is it the aesthetics? Is there blocky bits? Is it overexposed, underexposed? Contrast is high, contrast is low. So what we did is we built a model that takes into account 13 different scores of a video and actually directs the encoder on what type and what algorithms to use in order to make that much more efficient. So how does it work? So the first thing we do when the video comes in is we classify it into our encoders. We need to understand, is it sports? Is it UGC? Is it PGC, premium content? News, something else. If we know that, then we can already start thinking, if this is sports, there's probably going to be a lot of jerseys. We should kind of start thinking about jersey detection. We then look at the quality analysis as we just talked about. If the video comes in, it's really, really good quality, we probably don't need to spend as much time firing up the denoise filter or the dehaze filter or something like that Ramesh was talking about. So if we know that it's good, we can pass it straight through. We don't have to use as many algorithms. If it's kind of in the middle, we can do things like enhance the video. We spend a little bit more time. If it's going to be viewed millions of times, spend time, make it look better. If it's poor, you can probably reject it. In the case of some companies, they do that, and spit it back to the user and say, that content's just not very good, garbage in, garbage out. If I encode something that's very poor, the chance of it making it look better are pretty slim. So once you've done all of this, you then know kind of with those 13 subscores of the quality, kind of what things to do, what regions to look at, what rate control to use, what partition structure, what modes to use that we showed in the first slide, and can make those adaptations. So our solution, as we talked about, uses neural networks to understand videos, uses machine learning to make decision-making processes, and we do a lot of work around ROI. Most of our customers also have custom content. So we take in content from our customers, we tune the encoder, we recompile it, give it back to them to run in their cloud or on their premises. and the results speak for themselves. So I think this is going to be pretty visible here. Sorry, it's a little bit washed out, but with encoding with intelligent optimization, you can see a 720p output here. On the left-hand side, we have our competitor. Its output at 848 kilobits per second. This is ABC, by the way. The VMAF score, which was talked about, is an objective quality metric, came out at 91.07. On the right, we're using our Aurora 4, which is our ABC product. We're able to shrink that bit rate down by around 35%. But actually also, because we do things like improve the region of interest in the faces here, actually boost that VMAF score, to which we think has superior visual quality. One more thing I'll show here. This is, people say, well, that's great. Is it standards compliant, right? Are you doing anything interesting or different in the codec that makes it so much better? And no, the answer is no. Everything that we do in our codecs, ABC, HEVC, and AV1, is 100% standards compliant. So you don't need a custom decoder or anything like that to play back our streams. In this case, we're comparing Aurora 5, which is our HEVC encoder, against our X265 here on the left. You can see the output here at 4 megabits per second. The processing speed, again, was those three levers: speed, quality, and size. The speed was, the encoder was running at 79 frames per second. And the VMAP output on the left from X265 was 94.41. When we ran that same file through our encoder, targeting basically an equivalent quality, we wanted to see how much bit rate we could save. We were able to actually slightly increase the VMAF, but drop the bit rate down to 2 megabits per second. Our HEVC encoder is also very, very fast. So you can see it was running at 301 FPS. And so as you think about your compute footprint, our HEVC encoder is very, very, very efficient. I did have one more. Sorry, I have one more in here for Aurora 1. So we talked a little bit about AV1, a new open source codec that's come out. We're seeing a lot of adoption of that in the market. Many, many premium OTTs, streaming services, RTC solutions, defense industries are starting to use AV1 because it really, really drops the bit rate compared to other codecs. It does take a little bit more time. It's a more complex, it's a newer standard. It's not as old as we talked about as ABC or HEVC. And to that point, you can actually shrink things down to 100, 200, 300 kilobits per second and still get usable video out the other side. In this case, we're comparing an Aurora 1 output to LibAOM, and you can see we saved around 35%. One of our customers in 2023, Snapchat, started to deploy our HEVC encoder last year and ended up saving millions of dollars on the delivery costs. Because you think about it, if you're doing video at that size, that scale, putting 30% reduction into your egress, your storage, your CDN costs is quite meaningful to those types of companies. And lastly, I would like to say, we think about all of the things we've built. The question is, well, how can you use it? We can deploy our AI engine inside CPU plus GPU. We can deploy it in our Aurora Cloud VOD and live service, which is a SaaS service we host on GCP and AWS today. We can give it to customers as an SDK that they can compile into their own FFmpeg or GStreamer, as we say. And lastly, but not leastly, we can also use it for image-based processing as well, because all this work that we're doing for videos are basically sequences of images, right? We work on HEVC, AVC, and AV1 for VOD, live, and RTC use cases. We have around 100 customers today. Some of them, the logos you'll see up here, from different platforms, premium VOD, partner relationships. We do a lot of work because of the scale in the UGC space. And so you'll see a lot of logos here. Some of them you'll know from India, some also from US and other regions. And then WebRTC, our product, our AV1 product, works especially well for RTC, and then also for live streaming. We have around 100 satisfied customers today. We're very, very proud that we're a deep engineering-based company. We have 100% retention of our customers. Our customers have encoded more than 10 billion videos, and we've helped them save more than 5,000 petabytes in CDN delivery costs. So let us know if we can help you. Thank you.